So how would one determine the point group of a molecule? That's the question that we want to address in this video. We'll assume that we already have an idea of what the various symmetry elements and symmetry operations are for the molecule. So how would we put those together to actually come up with a point group classification? All right, I'm going to describe a systematic way of using several steps to determine this. And frankly, one of the best ways is to simply compare it to molecules with known point group symmetry that are similar to the one you have, and hopefully you find one that matches. But let's go through this systematic way. Okay, the first element of a systematic approach would be if you have a molecule that has no obvious symmetry. So I'll just say no symmetry. And there are going to be two main possibilities that you'll run into here. One is that you will assign it to be C1, all right, no symmetry. The other is that you'll assign it the symmetry CS, but this would only be true if your molecule happens to be planar. All right, so limited type thing, but believe it or not, most of the molecules that you're probably going to deal with in the lab probably fall into one of these categories unless they have some special symmetry of some kind or other that is useful for you. All right, so let's suppose now we have a molecule that does have some symmetry. There are a couple of questions that we might ask. One, is it linear or nonlinear? So I'll just say linear. And if the answer is yes, then we would have one of two possibilities. As we mentioned before, will either be C infinity V or D infinity H. And the difference between these are going to be whether the molecule, the linear molecule, is symmetric about its midpoint. All right, the next question that we might ask about this, let's suppose that the answer was no. So if no, then we go to question 2, and we would say, does it have multiple high-order rotation axes? So when I say multiple high-order axes, I mean with n greater than 2. Okay, it's very unusual to find a molecule that has more than one high-order rotation axis. It will have one, and then the rest of its rotation axes will all be C2 axes. So if it has multiple, then the chances are it belongs to one of those cubic groups. So it's going to be one of the following. It's either going to be a tetrahedral base group, so it'll be T, TD, or TH, and of these, TD is the one that you'll find most familiar in some ways, because that's the group for methane. Or it'll be octahedral. There are some other cubic groups that it could belong to, and so if it's neither of these, then you'll have to look through some sort of group theory book to find which one it belongs to. But these, again, they're going to be relatively easy to recognize just because they have so much symmetry, it's hard to hide it. It's only going to be these. Now the third sort of yes or no point, so this is no. The question would be, does it have an SN axis but no CN axis? Okay, so has SN axis but no CN axis. This is actually a fairly rare occurrence, and so chances are the answer to this question is going to be no. But if it's yes, then the following possibilities are the ones that you should look out for. It could be S2, S4, S6, S8. It's going to be an even number, generally speaking, because the odd number ones will have a distinct CN axis with them. All right, so this is a possibility, but I would say this is a very uncommon possibility, so I wouldn't rest a lot of confidence on finding one with this particular symmetry. So again, we'll go no. And so now we're getting into the more common grounds that we'll find. And then so does it have a CN axis? And n can be any number now, 2, 3, 4, 5. Okay, and in particular one that is not derived from SN. All right, if it is derived from Sn, then it's probably going to be one of the S group point groups. All right, now there's going to be two possibilities here that we need to consider. Okay, so I'm going to draw a little split here. And one of these possibilities that it has no C2 axes perpendicular to Cn. No C2 axes perpendicular to Cn. The other possibility is that it does have C2 axes perpendicular to Cn. So all right, so you look for that particular indicator. Now, in the case where it does have or does not have C2 axes, well, actually, with either one of these cases, there are several possibilities that you also have to look for. Okay, one is, does it have sigma planes? And so if the answer is no, so I'll say no sigma planes, there are two possibilities that come out here. If it has no C2 axes, then this will be simply a Cn point group. If it does have C2 axes but no sigma plane, then we would call this D sub n as its point group. All right, a second question that we might ask in this case is, does it have a sigma h plane? Okay, if it has a sigma h plane, again there will be two possibilities depending upon the presence of C2 axes. If there are no C2 axes and it has a sigma h plane, then we would call this point group CNH. If it has a CH plane and it also has C2 axes present, then this is a point group we would call D sub NH. Finally, we would, if both of these are false or not true, then we would come down and ask, does it have sigma V planes present? And in this case, we'll again have two outcomes. In the case of no C2 axes perpendicular to the Cn axis, we'll end up with a point group that we would call C sub NV. If it does have C2 axes, then these actually will be sigma D planes, and the designation for the point group would be D sub ND. All right, so this gives us a nice rundown for how we can narrow things down and get to a point group that designates the symmetry of the molecule. Now, I want to illustrate this with what I hope will be a relatively quick example, but I want to go slowly enough that you can follow what we're doing. We're going to check out the point group for butadiene. All right, so this is a molecule that looks like this. All right, now one has to consider this carefully. It is a planar molecule, but it clearly has symmetry, so it cannot be C sub S. All right. What I'll note here is that if I were to put an axis perpendicular to the center point of this molecule and rotate it by 180 degrees, I would get the same molecule back. So it has a C2 axis. It also lies in a plane, so it has a sigma h plane because that plane is perpendicular to the C2 axis. Now, one that might be a little bit harder to recognize, but important in this molecule, is that this center point is also a point of inversion. So, for example, this carbon, if I invert, it goes to that carbon. This hydrogen, if I invert, it goes all the way to that hydrogen. So you can see that every atom in this molecule has a counterpart that I can get to by inverting straight through that center. All right, so that inversion center adds yet another symmetry element. And when we add our final, our identity element, these constitute the elements that we have for this particular molecule. All right, so as we go through our list, okay, it's not a linear molecule, so we go to the second one. It does not have multiple CN axes, so we can skip all of that. It does not have an SN axis without a C axis. So we're down here to having a CN axis. In this case, it's a C2 axis. There are no other axes of rotation. Okay, so if you imagine, for example, trying to rotate about this, I will not get the same molecule back. I'll get sort of its reflection back if I rotate around this. So that is not a C2 axis that's perpendicular to the one that is the principal axis. So it has no C2 axes perpendicular to CN. It does have a sigma plane, so this is not true. It has a sigma H plane, so this is true. So what this gets us down to is CNH, which we would identify for this particular molecule as a C2H point group. And that is, in fact, the point group for butadiene. All right, so I hope this has helped you figure out how you might use this information to arrive at a point group for a molecule. It does take a little bit of work, and you need to be very careful that you have all of the symmetry elements and operations handy when you go about identifying this. But this systematic procedure will help shortcut that process for you so that it will quickly get you to the right answer.